For this first problem, we want to start by looking right in the center of the parentheses to see that there's no addition, there's no subtraction, so this is a multiplication problem. And so for multiplication, you have two choices. You can either use the distributive method or the box method. And I'm going to quickly show you both because whichever you prefer, I want to make sure you see how to do it correctly. So the distributive method, we just distribute the very first term to everything in the second polynomial. And we use arrows to kind of keep our work straight. So when I multiply this, remember you multiply the coefficients out front to give you 6. And then I have 2 x's here and I have 1 x here, so I have x to the third. We add those exponents. That's a very common mistake, so just be on the lookout for that one, is accidentally forgetting to add this x to the 1. Then we want to go back and take this and distribute again to this. So we have 3x squared times -1 to give us -3. And then I just have the x squared from here. Nothing's here, so I bring down x squared. Then you go and you repeat that process with the second term. And so I usually do these arrows underneath. So I do the first term on top, the second term underneath. If you had more terms, your arrows might start to go like across each other, which is okay. So down here, -4 times 2 gives me -8. And then I have an x I need to bring with me. You could put the exponent of 1 if you want. You don't have to. And then back, -4 times -1 gives me a +4. That's also a common mistake. Make sure if you have a negative times a negative, you write down the positive. So now I just want to make sure that my answer is in standard form and I have no like terms. So in standard form, I have exponents highest to lowest. So 3, 2, 1, none, which is good. And then I do not have any like terms because none of these have the same exponent. So this is my answer. And so that was the distributive method with the arrows. For the box method, you simply want to draw a box with the same columns and rows as your terms in these. So since I have 2 terms and 2 terms, my box is going to be a 2 by 2. 2 columns, 2 rows. Make sure you make your box big enough that you can write on the inside. And then I'm going to line up one of my polynomials with the top and one of my polynomials with the left. It doesn't matter which one, so I'm just going to do 3x squared minus 4 here, and then 2x minus 1 here. And I am going to draw in that exponent of 1 so I don't forget it. Again, common mistake with both types is to forget that exponent. But with the box method, you're going to use each row and column, and you're going to multiply to get the inside of the box. So I'm going to take 2x and 3x squared to get this box. So 2 times 3 gives me 6. I have 2 x's and 1 x, so I have x to the third. For this box, we want to use the -4 in the 2x, so I get -8x, or -8x to the first. For down here, we want to use 3x squared and -1 to give me -3x squared. And down here, we get -4 times -1 to give us +4. And so for the box method, I just got to do that extra step of pulling it out of the box, combining any like terms if I have them. In this case, I don't have any like terms, so I don't have to worry about that. But pull them out in order. So I have 6x to the third minus 3x squared minus 8x plus 4. If you pull them out of order, you'll have to reorder it once you get to this step. So create less work for yourself by ordering it when you pull it out. So that was each method. And again, Miss Leffy and I do not have a preference on which you would like to use. So you can choose which one is best for you or best for that problem.